Welcome back to Database Management System classes, Chapter 2, Entity Relationship Model. In this chapter, we will discuss about the entity relationship model. Model means design. The topics that is to be covered: overview of the design process, the entity relationship model, different types of attributes, the mapping cardinalities, primary key, and removing redundant attributes in entity sets. Now, starting with the design phases. If we need to design the database model, then we have to put emphasis on some important phases. The initial phase, where we characterize prospective database users' data needs. In the second phase, choosing a data model is the main concern, as well as conceptual schema of the database that we need to design, as well as describing the kinds of operations that will be performed on the data must be taken care. The implementation of the database in the final phase. Firstly, the logical design, where we have to identify the entities. That means database design requires that we find a good collection of relation schemas, and business decision like attributes should we record in the database. That means we have to identify what are the attributes that we consider to be important for our database. And finally, we should have those attributes distributed among different relations. And physical design is also very important, deciding on the physical layout of the database. Now, in the design phase, we have to avoid two major pitfalls. Number one is redundancy, and the second one is incompleteness. If in a database we put the same information again and again unnecessarily, that information is called as redundant. So, we have to be very careful that we must not put any redundant data. And the second one is incompleteness. A bad design may make certain aspects of the enterprise difficult or impossible to model. So, that incompleteness must not be there. That means some important features are not included in the database, so that will lead to a bigger problem while the entire database is created. So, not only avoiding the two major pitfalls is important, but also it is important to have good collection or good designs we have to incorporate in our database. Now, starting with the discussion on ER model, the database modeling part. ER model was developed to facilitate database design by allowing specification of an enterprise schema that represents the overall logical structure of a database. So, entity relationship model basically contains three major parts. Number one is entity set, number two is relationship sets, and the third one is attributes. Now, the ER model also has an associated diagrammatic representation that is known as ER diagram, and it can be expressed in a logical structure way. So, the graphical representation of the logical structure of the database is known as ER diagram. Now, starting with the first point, that is entity sets. An entity is an object that exists and is distinguishable from other objects. Let's say, for example, person, dog, company, event, plant, school, college. Each and everything is known as an entity set. Entity set must have some characteristics, and those characteristics are called as attributes. Say, for example, instructor is an entity, so the ID, name, salary, all these are different attribute set for that instructor. Now, one more important thing here is the primary key. A subset of the attributes from a primary key of the entity set, that is uniquely identifying each member of the set, that is called a primary key. Now, let us give an example of two different entity sets here, instructor and the student. Instructor ID and the name are given in the left side. So, this is the instructor entity set, where this is the ID at the first column. This column contains the IDs, and in the next column these are what? The names. So, this is instructor names, fine. Now, here this is the student table, where this is the student roll number or ID, and this is the name of the student. Now, coming to the next part, where we will detail how the entity sets are drawn in a graphical way. So, here you can see rectangles are there to represent an entity set, and their corresponding attributes are represented in ellipse graphical representation. And here in these boxes, these are two different entities, one is instructor and another is student, and here you see there is ID, one field or column or attribute, whatever we can say, is ID, and that is underlined. So, normally the general representation of primary key is via this underlining feature is being used. Now, coming to the next one, that is relationship sets. Okay. So, instructor is an entity, student is an entity. So, instructor advises student. So, this verb advises is the name of the relationship between this instructor and student entity sets. This can also be mathematically expressed, like here the example that 44553 Peltier, this is one instructor, no, this is a student entity, and that is being advised. The relationship is set is named as advised, and its advisor is this instructor Einstein. So, this is how mathematically it is represented, and it can also be written like this. And here one thing is very clear, that the number of entities must be greater than 2. So, n greater than equal to 2, there could be more than 2 as well. If there are 2 entities involved in a relationship, then that relationship is known as binary relationship. Okay. So, here we see that instructor and student, these are two different entity sets, and they are interlinked, means one is connected to another. Who is the advisor of which student, means which instructor is connected to which student, that particular thing is mentioned over here. Now, the diamond represent relationship sets, so that we already shown in the previous slide, and here this is the entity in a rectangular box, this is also an entity, and they are connected through this relationship, this one. Here one thing we should mention over here, that the relationship name is not a name, it basically always a verb, so it should be advises. So it will be like this, and if the student is at the left side and instructor is at the right, then it would be advised by. So active voice and passive voice, that we have to be very careful. And one more thing here I should mention, that whenever we have to read the diagram, either we should follow left to right or from top to bottom. So left to right or top to bottom. This is the way how we are reading the diagram, basically the ear diagram. So from top left corner to bottom right corner. So this is the kind of vector. Okay. Anyway, so coming to the next discussion topic, here also let's say this is an attribute. This instructor is connected with this particular student. On a particular date they were being introduced to each other. So this particular attribute says that on this particular date both of these instructor and student introduced to each other or associated with each other. So this is kind of attribute set. Now coming to the next description of this particular relationship, we all know that mostly the entity sets are connected with the attribute, but here the relationship set also has the attribute. Now how it is becoming an attribute of a relationship set? In the last example we show that this instructor Creek is connected or associated with this student Tanaka on 3rd May 2008, let's say. So this is the date of association, and this is the student and this is the instructor. So the instructor is the advisor who is associated on this particular date. So this date becomes the attribute of this relationship set. Now few more things we need to know about the ER model. Number one is role amongst them. So what is the role? Let's say this is the course entity. Course is having the ID, title and credit. Now course ID, and this is a prerequisite ID. So there is a relationship which is called as prerequisite. So at the beginning of our lesson we also mentioned about our prerequisite knowledge required for our database management system learning. So prerequisite ID means what are the IDs which are required, means that could be an identifier of some other courses. Means for learning this particular course DBMS we need to learn some other prerequisite courses, let's say for example mathematics, data structure and few more other subjects. So this is what the prerequisite relationship here is. So each occurrence of an entity set plays a role in the relationship here. So that is denoted as the role. Now coming to the next topic, where we will discuss about binary and ternary relationship. Binary relationship is very simple, like doctor treats patients. So doctor and patients are the entity sets involved, and treats is the name of the relationship, where we can say that this is a binary relationship. And this is little discussion about the binary relationship. Mostly the ternary relationship occurs very less, but I will give an example here about the ternary relationship as well. Before that we need to understand what non-binary relationship sets. Though we know that most of the relationships are binary, like teacher teaches students, doctor treats patients, nurses helps doctors, person owns dogs, etc. So all these are example of binary relationship, but there are occasions when it is more convenient to represent relationships as non-binary. So in year diagram with a ternary relationship as well. So here this is an example of ternary relationship. All these three are different entities, and three entities are connected to a one relationship, project guided or project guided by. So this is the relationship name where these three entities are connected. So it is self explained, so we need not to explain anymore, just look at this. Now coming to the next concept, that is attribute. What are the different types of attributes are there in year model? First, simple attribute, and the simple attribute are denoted, simple or composite, they are denoted by simply this ellipse. The single valued and multi-valued attributes are also very important. Someone might have more than one phone number, so that phone number attribute is a multi-valued attribute, right? Now coming to the next attribute type, that is called stored versus derived attribute. Let's say age is derived because from the given date of birth we can there is stored attribute from which we can determine the age. Let's say someone birthday is in year 2000, so 1st January. So in 2020 1st January will be the age of him will be 20 years. So date of birth 1/1/2000 is the stored attribute, whereas the age which is derived from that particular date of birth is nothing but a derived attribute. As simple as this. Okay. So derived attribute is represented by a dotted ellipse. So this is what it is, and the composite attribute, then multi-valued attribute, the double ellipse is used. Now coming to the concept of domain, let's say what is a domain? Let's say there is a table called student, and student is having ID, right? So there are few IDs like 2, 4, then 7. So all these are what? IDs. Now ID is a domain or field or column or attribute under which there are 3 different IDs are given. So this is the set of values that ID attribute permits. So this is called the domain of the attribute ID. Okay. Now coming to the next concept, the composite attribute. The composite attribute means attribute which can be divided into parts, and the division or the sub parts must be meaningful. Like atomic attribute is indivisible, that means we cannot reduce it. So that is an atomic attribute or simple attribute. But if we talk about the composite attribute, it can be divided into parts. Okay. So for example, the name, better to say a full name, right? Full name is, we can say it is a composite attribute because it can be divided into parts. There are few more parts like salutation, Mr., Mrs., etc. So salutation we can put at the beginning. Okay, salutation. Like Mr., Miss, etc. And then the first name, let's say Raju Srivastav or Rajendra Narayan Srivastav. So these are different parts of the name of one person. So what we say is that this full name is a composite attribute, right? That because it can be divided into parts. Similarly, address is also a composite attribute. It can have multiple sub parts which are definitely meaningful. If we have non-meaningful subparts, then that is not a composite attribute, but here address can be divided into subparts and they are meaningful, so we can say this is a composite attribute. Now coming to the complex attribute. Basically complex attribute is multi-valued plus composite. Let's say some person is having two addresses, like winter and summer houses are there for him, for a person. So the winter house address and summer house address, so address is multi-valued as well as composite. So that is why it is termed as complex attribute. Okay, so complex, you now get the idea about it. Complex is nothing but multi-valued plus composite. And here also some examples are given in this. So going to the next, cardinality constraints and how it can be mapped. Let's say I am a person. So person is a what? Person is an entity, and I have few pets. Let's say I have 4 dogs. So dog is another entity. So how many dogs I have? 4 dogs. So person is having the cardinality to the entity dog 1:many, because one person is having many dogs. So the cardinality ratio will become 1:n, 1 to many. Whereas if I have one laptop, so person and laptop, so 1:1. Okay. Suppose I have only one job. Okay. So person and job, they are 1:1. The ratio is 1:1. So this is how the cardinality is there. Let's say many to one. Many to one means let's say the students I am teaching, they are many, and one teacher is teaching to them at a time. So that is the relationship many to one. Sometimes many to many. Some games are being played in a group. So in a group there are many people playing against another set of people. So many to many relationship is maintained there. So this is how the cardinality constraint is defined. This is a pictorial representation of mapping constraints. A and B, two different entities where there are different entity sets, instances are there which are connected to one with another. Sometimes it is one is connected to a single one, so it is 1:1 cardinality, and sometimes it can be any one can be connected to many of the other, so that is called 1:many. Okay, so this is how it is defined. So this is 1:many, and many to one is also defined here. It is also easy to understand, because 1:many, if you understand, many to one is also just reverse. And many to many means a single one is connected with multiple, and one of them is reversely connected to multiple. So you see the overlapping is there. So it is clear that this is called the many to many cardinality. Okay. Now representing cardinality constraints in ER diagram. This is very important part of this ER diagram representation. And if it is only one entity is connected with one entity, so then we use this arrow sign, and this is basically this arrow sign means a single, only one is connected with another one. Okay, so that is why this arrow sign is there. Now here you see one side there is arrow sign, that means here one instructor is connected, but if there is no arrow sign here, that means there might be many students connected to this particular entity set. Sorry, with this relationship many students are connected, but only one instructor is connected at a time. So one instructor is advising many students, so 1:many relationship is maintained here. So this is the representation. The thing that you need to focus is, if it is one instructor connected, then you have to put arrow, otherwise no arrow. That's it. Now many to one, the reverse thing that I have told just before some time, there is no arrow here, only arrow here. So this is what many to one relationship. That's it. and it is many to many. Both side there is no arrow, that means here also many is connected, here also many is connected. So that's it. Now total and partial participation, this part must be understood, and here you see there is a double line. If it is not clear to you, you see here we have a single line, but here it is connected via double line. So double line represents total participation. So here if you see the word total participation, the double line means total participation. What exactly it means? Means this relationship involves all the students, no students is left. Means every student is assigned to some particular instructor. Like in our college we have mentorship. So one faculty is assigned with many students who are their mentees. So no student are left. That means it is not possible that any student are left without any mentor. So the mentorship relationship occurs, and there all the students are involved in that particular relationship. So that is why all the students are involved in this particular relationship. But in this example, here we have a single participation link, that means it is partial participation. There are some instructor who are not yet assigned to any students. There could be possible that some instructor, let's say some HOD of the department who is not taking the class, only doing the administrative jobs, then that instructor is left, kept aside from this particular relationship. Maybe he is or she is not participating in this relationship. That is why if all the instructors are not taking part in this particular relationship, then there is a single line. But all the students are involved in this relationship, means they are getting the advices from at least one instructor. So that is why there is total participation. Okay. So this is how we have to understand this. Now notation for expressing more complex constraints. Complex constraints like instructor, there may be 0 to many instructors who are participating in this particular relationship called advisor. It should be advises, because it should always be a verb in the relationship name. And here the student is the entity where the instructor is advising one student or many student. Okay. 1 dot 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 n means if an instructor is advising at least one or more than one. Okay. So here it is written clearly that a minimum value of 1 indicates total participation. A maximum value of 1 indicates that the entity participates in at most one relationship. A maximum value of star indicates no limit. Okay. So this is how it is constructed, means this is a little complex interpretation of the kind of year modeling cardinality constraints. So this is very simply it is defined. Now cardinality constraints on ternary relationship will also be very important. Like in ternary relationship, the cardinality constraints are between any two pair of entity sets, because amongst 3 entity set at a time we cannot define the cardinality. So if there are ABC 3 different entities, then take any 2 of them and define the cardinality set between those 2, that is the pair of entities, and separately you take another pair of entities amongst which you can put the cardinality, and that is how whatever cardinality we know, 1:1, 1:m, m:1 or n:m. So those can be applied on those pair of entity sets. Okay. So, this is a clear cut picture for ternary relationship. Separately I have put it for you. Doctor is an entity, patient is entity, medicine is entity, and prescribes is the relationship name, and the dose depends not only for a particular patient, not only for a particular doctor, or not on the medicine that is being prescribed. It depends on all these three. So, the prescribes relationship have these attribute dose that must be considering what patient is, what disease he is having, what medicine is prescribed, and which doctor. So, based on these three, the dose will be determined. So, dose is the attribute of prescribes, not for patient, not for medicine, not for doctor. Patient has patient ID, the disease diagnosed, medicine has medicine ID, expiry date, price, etc. Doctor has registration number, specialization, etc. These are their attributes. But here dose attribute is very key attribute, because depending on the medicine and doctor, the patients are prescribed with a particular type of dose, right. So, this is an example of ternary relationship. Now, the discussion on primary key. Primary key is a set of attribute that can uniquely identify a tuple in a relation. So, for every entity to identify an instance of that particular entity, we should have a primary key to separately or distinctly identifying a particular entity set. Now, by definition, individual entities are distinct. From database perspective, the differences among them must be expressed in terms of their attributes. A key for an entity is a set of attributes that suffice to distinguish entities from each other, right. And here it will be the description of what the entities are basically distinctly determined. So, if we have the relation R, and which contains E1, E2, these are different entity sets, and every entity set must be determined by a primary key, and if primary key exists, then all these entity sets can be made union to do some operations, especially the join operation or so. If the relationship set R has attributes like A1, A2 and AM associated with it, then the primary key of R also includes the attribute A1, A2 and AM. For example, the relationship advisor, the primary key consists of instructor ID and the student ID. Okay. The choice of the primary key for a relationship set depends on the mapping cardinality of the relationship set. That's it. Now, who choose the primary key? That is depends on the database administrator, programmer, or whoever is there responsible for maintaining the database takes the decision that which one will be the primary key. There could be more than one attribute qualifying for the primary key, but it is the decision of the database administrator or the programmer. They take the decision based on the application which will be the most fruitful primary key for the given set of qualified list of attribute set. Okay. Now, this is again the different cardinality ratio, many to many, one to many, and many to one relationship, one to one relationship for understanding of the primary key. So, we are moving forward. This is the discussion on the concept of weak entity set. This is very important. Weak entity set is a particular entity set where the attributes are not sufficiently enough to identify that particular entity. Okay. Let us say, for example, a person is working in a company and he has some dependents. Now, if that person leaves that organization, then the dependents will also cease to exist. because they will not get any medical benefit from that particular company, right? So what exactly we need to do is we have to uniquely identify the dependents. How we can uniquely identify the dependents? The dependents are having the dependent's name, fantastic, but that name is not able to distinguish the dependents, because with the same name there could be multiple people in the list. So to identify every dependent, we need to attach the primary key of the employee whose dependents they are. So along with the primary key that we are hiring from the employee, along with that the dependent's name, both of these are attached together to form the primary key of the weak entity. Then only it is possible to identify the weak entity. Otherwise, whatever attributes are already there in the weak entity, they are not qualifying to uniquely identify an instance of the weak entity set. Okay, that means they are not able to uniquely identify a row or tuple in that weak entity set. Okay, so this is the discussion of weak entity. Here you will get some example like section entity, course ID, semester, year, etc. there, and this is the explanation, and whatever I have also explained, that is also an example of weak entity. And if you go through this, this is also an explanation of the weak entity set. Okay, and this is the continuation of that. So you can also take reference of this particular example. Yes. So in nutshell, we can say a weak entity set is one whose existence is dependent on another entity, and that entity is called the identifying entity. The example that I have given, the employee, that is the identifying entity, and the dependent, medically dependent maybe, so they are called the weak entities. And the name of the dependent entity or attribute of the dependent entity is a partial key, we can say, but not a primary key. Why we call a partial key? Because that can discriminate few of the people in the dependent list, but that cannot uniquely identify. That is why that is known as the discriminator. Now we have to take the help of the strong entity set, hiring the primary key of from there and attaching it with the discriminator. We can create the primary key of the weak entity set. Now here is the detailed explanation of the weak entity. Course ID, and this is the identifying relationship, the total participation of the section. If the course is not there, the section cease to exist. Okay, so section will be there if the course exists. So that is why section is having total participation, but the course it does not. So this is the weak entity W, and this is the strong entity S, course, and this is the identifying relationship IR, identifying relationship, and this is strong entity, or this is strong entity or identifying entity. So this is how the weak entity is determined. Now going to the redundant attributes. Suppose we have entity sets, the student with attribute ID, name, total credit, department name, and some department with attribute department name, building, budget, etc. So here the model the fact that each student has an associated department using a relationship set stud underscore DEPT. Okay, so this is the relationship set, but here you see the attribute department name in the student table and replicates information present in the relationship and is therefore redundant and needs to be removed. But when converting back to the tables, in some cases the attributes get reintroduced, as we will see later, but this is how the redundancy occurs in this case. Thank you so much. We will meet again in the next class, where we will be discussing the extended relational algebra operations or features like specialization, generalization, aggregation, inheritance, etc., and how we can draw the ER model for a particular application. Till then, thank you so much. Bye bye.